Hi everyone, welcome to my channel. In this lesson, we will learn how to solve the inverse and adjoint of a 3 by 3 matrix. So let's begin with the example. So here in this question, just to mention, how do you know the order of the matrix that it is 3 by 3? Because it has 3 rows, which is row 1, row 2 and row 3. And it has 3 columns, column 1, 2 and 3. So inverse is actually the representation of an inverse of a matrix is 1 divided by determinant of A times adjoint of an A. So let's see how to find the determinant of A. And yes, provided this determinant of A should be non-zero. Why? Because if determinant of A is 0, then what happened? Then 1 divided by 0 is not defined. So the condition to find the inverse is the determinant of A should be not be 0. So let's find out how the determinant of 3 by 3 matrix. So the first thing is you need to look at the element corresponds to first row and first column, which is 1 in this case. So it's minus 1 to the power 1 plus 1 corresponds to A11 times A11 is this 3, and then you will find the determinant of an element not corresponds to first row and first column. So in this case it will be 4, 3, 3 and 4. Because if you don't look into this and this column, then it's 4, 3, 3 and 4. And therefore, now the next portion is looking into A12, which is minus 1 to the power 1 plus 2 times the column 2 element is 3 times the determinant for the elements other than row 1 and column 2. So if you leave row 1 and column 2, you will get 1, 1, 3 and 4 plus minus 1 again to the power 1 plus 3 times the element, which is 3 times the determinant. So other than row 1 and 3, it's 1, 4 and 1 and 3. So if you don't look into the elements other than first row and third column, the elements left are 1, 4, 1 and 3. Now let's solve this. So what this becomes? This is minus 1 square. That means minus 1 is multiplied 2 times. So negative gets cancelled. So this becomes 1 time 1 time. Then you have to find determinant for this 2 by 2 matrix. So this will be 4 times 4. We will write it 16. 4 times 4 minus 3 times 3, which is 9. Then plus, this is minus 1 cube, which means minus 1 is multiplied 3 times. So the pair negative sign get cancelled, but you left with 1 negative sign. So this becomes minus 1 times 3, and then you need to solve this. So this becomes 1 times 4 is 4 minus 1 times 3 is 3. Then again this becomes minus 1 to the power 4. That means minus 1 is multiplied by 4 times. So it's an even number, it will spare, minus 1 get cancelled. So this becomes 1 time 3 time, this becomes 3 minus 4. Now when you subtract 9 from 16, it's 7, and if you multiply by 1, it's 7, and then 4 minus 3 is 1, and when you multiply by 3 and minus 1, this becomes minus 3. And then you have 1 times 3 is 3, and then plus and minus is minus. You subtract 3 from 4, it's 1, and bigger sign is negative because 4 is the largest number. So this becomes, and then 3 times minus 1. So this now becomes plus minus minus 7 minus 3, and when you multiply this, this is minus 3. So negative, negative, positive. 3 plus 3 is 6. So this becomes 7 minus 6 because either of that, this number are large and it has a negative sign. And when you subtract 7 and 6, it's 1. So that means determinant of A is 1 and it's not 0, which means that you have to find the inverse. For that, you need to find now the adjoint. So now let's see how to find the adjoint of this matrix. So again, writing back the same matrix. So what this matrix is? 1, 3, 3, 1, 4, 3 and 1, 3, 4. Okay. So adjoint, in order to find adjoint, it's actually the transpose of the cofactors of each element. So the cofactors you write in terms of capital letter. So you have to find the cofactors for each element of this matrix. And whatever the answer you get, you need to find the transpose. Now let's find out the cofactors. So let's find out cofactor A11. So it will be minus 1 to the power, because this element is 1, small a 1, 1. So this minus 1 to the power 1 plus 1. And you have to write the elements other than row 1 and column 1. So it becomes 4, 3, 3 and 4. Now when you solve it, this becomes 16 minus 9, which is 7. Now this is minus 1 square, which is 1. Let's find A12. It will be minus 1 to the power 1 plus 2, and then all the elements other than row 1 and column 2. So it's 1, 3 and 1 and 4. So this becomes minus 1 to the power 3 is minus 1 times this will be 4 minus 3. So 4 minus 3 is 1, and when you multiply it becomes minus 1. Let's find A13. So again it's minus 1 to the power 1 plus 3, and then all the elements other than first row and third column. So first row and third column is 1, 4, 1, 3. And therefore this becomes, this is minus 1 to the power 4, which means minus 1 is multiplied 4 times and negative sign gets cancelled. So it's 1, and then times, you have to multiply 1 with 3. So it will be 3 minus 4. And plus minus minus, if you subtract 3 from 4, it's 1, and the largest number is 4, so it is negative 1. Now let's find A21. So this will be minus 1 to the power 2 plus 1, and again you need to put the elements other than second row and first column. So when you look and remove second row and first column, then it becomes 3, 3, 3 and 4. So let's do that. So it's 3, 3, 3 and 4. So what will this becomes? This is minus 1 to the power 3, which is minus 1 3 times, and therefore you get negative 1 times, you multiply this, it will be 12 minus 9. So if you subtract 9 from 12, it's plus 3 because 12 is the largest number, times minus 1 is minus 3. Now let's find A22 cofactor, which is minus 1 to the power 2 plus 2, and again you have to find the determinant for elements other than row 2 and column 2. So when you look, not elements this, so this is row 2 and column 2. So what are the elements left? 1, 3, 1 and 4. So now you're going to write that 1, 3, 1 and 4. So this is minus 1 to the power 4. This means you write 4 times. The pair gets cancelled. So this is plus 1 times, you multiply by this, this is 4 minus 3. So the answer is 1. Now let's find A, 2, 3. So again this will be minus 1 to the power 2 plus 3, and then you need to find the determinant for elements other than elements of row 2 and column 3. So no elements for row 2 and column 3. So you get 1, 3, 1, 3. So this is 1, 3, 1, 3. And again this is minus 1 to the power 5. So that means you write minus 1 5 times. You will get minus 1. Why? Because for pair it gets cancelled, but you will get the other one. So 1 times 3 is 3 minus 1 times 3 is 3. So this is 0. Anything multiplied by 0 is 0. Now let's find A, 3, 1 element, which is minus 1 to the power 3 plus 1, and again you have to find the determinant for elements other than row 3 and column 1. So when you go here, so row 3 and column 1, which you get 3, 3 and 4 and 3. So you're going to write 3, 3, 4 and 3. So this is minus 1 to the power 4, which is pair. This is plus 1, and then you multiply this. This becomes plus 1 times 9 minus 4 3s are 12. So you have to subtract 9 from 12. It's 3, and the biggest sign for 12 is negative, so it's minus 3. Now you find A, 3, 2, which is minus 1 to the power 3 plus 2, and again you need to look for elements other than row 3 and column 2. So if you again look back here, row 3 and column 2, not looking these elements, so it's 1, 3, 1, 3. So 1, 3, 1, 3. Now this is minus 1 to the power 5 times, which is minus 1 times 1 times 3 is 3 minus 1 times 3 is 3. So the answer is 0, because if you subtract 3 with 3, it's 0. The last one is A, 3, 3, which is again minus 1 to the power 3 plus 3. You have to find the determinant for elements other than row 3 and column 3. So you get 1, 3 and 1 and 4. So this becomes 1, 3, 1 and 4. Now this is minus 1 to the power 6. So the answer is plus 1 times, this will be 1 times 4 is 4 minus 1 times 3 is 3. So 4 minus 3 is 1. So therefore, now when you put these elements here, so what this becomes? This A1, 1, A1, 2, A1, 3, then you have 2, 1, 2, 2, 2, 3, 3, 1, 3, 2 and 3, 3. You have to find the transpose for this matrix. So substituting those values. So what is A1, 1? It's 7. Then you have A1, 2, which is minus 1. You have A1, 3, which is minus 1. Then you have A2, 1, which we find minus 3. Then you have A2, 2, which is 1. A2, 3 is 0. Then you have A31 minus 3, A32 0, and then you have A33 1. So once you find the transpose, that means this row now becomes column. So this becomes 7 minus 1 minus 1. This becomes again column minus 3, 1, 0. And again this becomes minus 3, 0 and 1. So this is adjoint of the matrix A. Therefore, A inverse will be 1 divided by determinant of A, which in this case is 1. So 1 divided by 1 times adjoint of A, which is 7 minus 3 minus 3 minus 1 1 0 and minus 1 0 1. So this is how you find the inverse of the matrix. So I hope you like this video. Please like, share and subscribe, and thank you for watching.